So today we'll be learning a bit about infra. What exactly is infra? Because there are people who are from other backgrounds. So I want to start with learning what an infrastructure is, and then we'll talk about cloud technologies, and then we'll start with AWS. So generally, in general sense, when we talk about infrastructure, we talk about like when we talk about building infrastructure, it means that there is an actual building or a tower or an apartment, okay, where you live. Okay, that is a physical infrastructure where we go ahead, live, and have our colonies or societies in. Okay, that is one infrastructure, but this is not same. Okay, in we call it infrastructure because this is where our code resides. Okay, so home, where you live, is also called infrastructure. Home where your code lives is also called infrastructure. Okay, when you live, you don't just call your home as infrastructure. Infrastructure also includes your garden, your play area, playground, everything, right? In code terms, okay, where your code resides, where data resides, everything includes an infrastructure. Okay, now let me give you an example. When you go ahead and click on google.com, okay, that request actually goes to a server, a Google server, which will go ahead, process that request, and send it back to you. Correct? Something that like that must have happened. So,
Yes.
example, if I am writing xyz.com, okay, it will go to a machine, okay, which is listed somewhere. Okay, I'll tell you more about where it is listed and what that IP means, what that domain means in some time, like in upcoming sessions. But you can just consider that every domain or everything that you write, like google.com, is pointed to an IP. Okay, now whenever you type that domain on your machine, it will go to a IP. That IP will process that request. That IP will have a code running in it. It will process that request and send it back to you. Okay, so now since it is going to an IP and where your code resides, it will go ahead, process the request, and come back. So this IP is of a system or of a machine. Okay, it is basically of a load balancer, but for simpler terms. Okay, because we have an audience here who doesn't understand a load balancer currently and other tool chain, so let's forget about a load balancer and other things. We'll only discuss about a machine. So very simple. Google.com, going to a server. Okay, a server where your code is running, your code will process the request and send it back. So this server is basically your infrastructure. Okay, now when we call server, it means a machine. Okay, it can be a Linux machine, it can be a Windows machine, Mac machine, any machine. Okay, generally it is always Linux machines because they have like uh, they are lighter, and as for servers we don't need a lot of UI, so we don't want to spend a lot of our processing, our RAMs and CPUs, memories, and all of that in a UI that we won't be using. Okay, so that's why we generally use a Linux system, which is kind of um, more optimized usage of your server uh, than in terms of a Windows or a Mac system. Now, do you understand now? Like a server is going to be just a system. Okay, it is going to be your system, my system. It can be any system. Okay, that system can be in a data center. That system can be kept in a server room. That system can be on cloud anywhere. Okay, it's just that IP is a public IP. is attached to that system. That public IP is assigned to this particular domain. As soon as you go ahead and reach that reach that machine through that public IP, there is a process that's running there which is going to serve your request. Okay. Now earlier there was something called as a monolithic architecture, wherein there used to be only one code for your entire application, which means one code for entire Google. Okay, one code serving everything. But then later on we realized that there is a lot of since our coding stuff is increasing, our requirements are increasing. Yesterday we understood that because we are in fast changing world, we want, like, our customers want some fast improvement in features, some fast new features being released quickly. So in a single code where everything is written, okay, so many team collaborating there becomes difficult. Example, you have one house, okay, and 100 people are living in that. You have one big house, big one, okay, and 100 people are living in that. Managing that house is going to be really difficult, right? Because everyone will have their own requirements, everyone will be doing something or the other, and it's going to be a havoc there. So better, instead of having one big house that is a monolithic architecture, let's bifurcate it in small fragments. Okay, every house or every component is actually serving a purpose. Example, if I have written a small code, that code might be just for payments. So this is going to handle all the payment related requests. So my request will come to one machine. One machine will then pass it on to, since it is a payment request, it will pass it on to some other machine that is solving all the payments part. One is solving all the account related login details. Another one is all the checkout, cart related details. So what I have done is I have different servers, okay, and I have different code. That code is specifically assigned to do a task. Okay, like that's how it is done in an efficient architecture. Like if you have 100 people, all of them are working on a same thing, it's going to become difficult because somebody is writing something else, somebody is writing something else, and integrating everything is going to become difficult. Okay, that's how it happens when you have a big house and hundreds of people living there. Okay, but when you have a small subset of people, okay, that's why we have in India so many states and all. Okay, because India is a very big country, so one system or few people managing everything is going to become difficult, right? So for that we have kind of bifurcated it in states. Every state is handling their own people. Now state level is also very big, so we have smaller levels, like um, your own representatives. Okay, those will handle their area, their small area. Example, in Rajasthan there's going to be someone assigned for this particular area, someone assigned for this area, this area, this area. So smaller the problem, easier it is to handle. Okay, so that's how we have done. Instead of doing a very big monolithic architecture where like that particular code is handling everything for you, we bifurcated into small segments, and small segment of code is called microservices. Okay, every microservice, like, it is created with a thought that this particular microservice is going to take care of this particular activity. Okay, like this particular person is going to, like, your CM is going to handle your state. Okay, so PM cannot go everywhere and handle everything, so there are CMs are going to handle their own states. Below CMs there are individual people who are handling separate sections. Like there's going to be education people, there's going to be education minister, there's going to be other domains as well, finance and all of that. So they are handling their own part. Correct? So it's just not PM which is holding everything. It's different people handling separate segments. Those are called microservices. So this architecture is called as a microservice architecture. Okay. So now we have, when we started, like initially when we started writing the code, as in back in some previous days, it was all monolithic where everything is written in one single code, but then we thought that it's growing rapidly. Okay. So since it is growing rapidly, it's better to have multiple segments taking care of single stuff. Now, earlier our architecture was easy, our infra was easy, as in there's one domain, one IP, everything is handled by that IP, because there's that code that's handling everything. Now it's not like that. There are different codes that are handling different stuff. Okay, we cannot put all of them in one machine, so we'll have multiple machines. Okay, 100, like 10, 20, 100, whatever set of machines we need. Okay, we'll have these many machines. All of these machines will have some or the other code running. We cannot have one domain pointing to everything. So we'll have one domain, like as in google.com, whatever you're writing on your browser, google.com, facebook.com, anything that you're writing on your browser is a domain. That domain is actually pointing to an IP. That IP will read what request you want to do, what you want to do here. What are you trying to do? Trying to check out, or you're trying to do you're trying to do some payments, you're trying to select a product. Whatever you're trying to do will redirect this request to a particular other machine where your code is running for handling that. Example, it's payments. You are going to write amazon.com/cart checkout or something. Okay, that will be pointed to one machine. That machine will route it to the checkout service or a checkout or a payment service which is running on another machine. That will process your request, send it back to this main system. This main system will send it back to your client, or from here directly to the client. Okay. Now, since there are more microservices, there are more servers that are needed. Now, you didn't ask me one question, that why don't we put all of these services on one server? Right? We can't do that. It means that all of them are sitting in the same house again. Okay, so that house is gone, everything is gone. Okay, plus you need a bigger capacity, like you need a mahal to settle 100 people in that mahal, right? So better to have separate small houses. Okay, every house is handling a specific activity, a specific task. Okay, and let them take care of it. Okay, now you guys understand what an infrastructure is. And infrastructure is all of this, like all these servers that I'm talking about here. Okay, servers, databases, everything. This is your infra, where your code lives. Okay,